The term electrolytes actually has to do with something that's dissolved in water, specifically something that's dissolved in water that will conduct electricity. If you've ever heard that you cannot be electrocuted in pure water, as far as I know, that's true. Pure water does not conduct electricity. If there are some ions in there, which most water has ions, then it will. So dissolving something is not enough. Actually, it needs to be an ionic substance, so you'll get charge will be able to flow through your water. So when you dissolve these two ionic compounds, remember, you know it's an ionic compound if you find a metal. Of course, sodium's a metal and calcium is a metal, so calcium chloride is an ionic compound, and sodium chloride is an ionic compound, and calcium nitrate is an ionic compound. So when you dissolve these, now not everything is entirely soluble, but these two are pretty darn soluble. Notice we can write them as a chemical reaction where we basically show it falling apart into the cation and the anion. So here's where the question comes in. Let's just say we're dealing with calcium nitrate, which is Ca quantity NO3 2. And let's say that we have, you go ahead and you prepare your solution that's 0.30 moles per liter of the salt, calcium nitrate. So I'm going to write 0.230 moles per liter of that. And the question at hand is, what is the concentration of the nitrate ion? So find the nitrate and put question mark molarity. So most times students will say, well, I bet it's going to be twice of 0.230, and you're right. The answer is 0.460 moles per liter of the nitrate ion. But can you get there using the factor label method? And I'll show you how that works. If we go ahead and make our first term the salt, the stuff that was prepared, the calcium nitrate, 0.230 moles of calcium nitrate per liter, then we can go ahead and introduce basically a ratio that says 2 moles of nitrate, NO3 minus, are formed for every 1 mole of Ca quantity NO3 2. So I guess what we're doing, basically, if you think about it, is using stoichiometric coefficients. So now our moles of calcium nitrate cancel, and we're left with moles of nitrate, which is wonderful. The 2 brings no uncertainty, and so we need to round according to 3 sig figs, so your intuition was right. You just basically double it. So the molar concentration of the nitrate ion is 0.460 moles per liter. Not too bad. So you're going to have some chance to kind of do this with some problems. So this problem will be due on Monday. We are going to get to the next assignment slide. So now notice the conditions for turning in this problem. You cannot just, you have to show your work, just like the example that I showed you a minute ago. So this is what these look like. Somewhere here. $13.79. There it is. Okay. So there are different salts: sodium sulfate, potassium carbonate, rubidium bromide. So in all of them, you are supposed to come up with the concentration of the cation and anion. Okay, so for instance, if we take a look at the first one, you're after, let's see, A. I would write it this way. I would go ahead and Na2 SO4 breaks apart to form 2 Na pluses and 1 SO4 2 minus. And then I would just put, in this case, we know 0.12 molar here, and question mark molar, and you'll be like, oh my gosh, I know it's 0.24 sodium ion and 0.12 sulfate. That's true, but you have to show it using a stoichiometric ratio, basically the stoichiometric coefficients. Okay. So we're going to work one more problem, and I'm going to kind of do we're going to work one more example problem, and I'll turn you loose on a couple homework problems, and then we'll call it a day. But in this next example, we need to remember one of the things that we know about solution concentration, or basically any sort of mixture. We can express any the weight percent of a component in a mixture this way. Okay, mass percent of component A, okay, by definition can be unpacked to mean grams of A per 100 grams of the mixture. So keep that in mind. All right, so this is the problem we're going to work. And I think maybe we'll go ahead and kind of write it on the board here. Now, I got markers the other day.
There's a bunch of me.
Yeah, but like I don't like the black one, it's Clare Ridge, and the other two are, so I think this will be good. Okay, so on a test or on homework or something like that, I really think this sort of chemistry problem, especially if you don't do a lot of them, it's kind of nice to draw a picture. So it says that we are going to dissolve 46.87 grams of isopropyl alcohol. And I learned isopropyl alcohol as IOH equals isopropyl alcohol. Okay, so 46.87 grams IOH, okay, is dissolved in enough water to ultimately give the final solution volume is 300 milliliters with 3 sig figs. That works. Well, there's not the question here. We're going to answer a few questions. Question number 1 is, what is the molarity? Now, if you run into this on a test, I really would unpack that. So I would write question mark, what is the moles of IOH, isopropyl alcohol, per liter of solution? That's our target. We can do that. Because actually here in a minute you're going to see we're going to take the grams divided by the volume, and then we're going to have to convert the grams to moles, and we're going to have to fix the volume from milliliters to liters. A follow-up question looks like this. It says, and actually they go together, what additional information would be needed to knock out the weight percent? So I'm going to go down to number 3 here. Number 3, I'm going to write question mark, weight percent. And just a minute ago, I reminded you what weight percent means. Here it means grams of IOH per 100 grams of solution. That's what weight percent means, because the solution is the mixture. Okay. And the answer to that actually is density. Number 2, the answer to that number 2 is density. And I'll introduce density here in a minute. Oh, it does say density. So density goes ahead and gives you, I'll write it up here. We won't need it for the first part, but we'll for the next part. Now, rho is the symbol for density, right? Density of this solution, which is isopropyl alcohol and water, is 0.975 grams per mil. Now, we cannot use that like that. You have to fluff it out, unpack it. So what that means is density is 0.975 grams of solution, SOLN, per 1 milliliter of solution. That's it. Okay. So I'm a firm believer in doodling. So like I said, what we are going to end up seeing us do here on the solution, no pun intended, is to basically take the grams of the solute, the grams of isopropyl alcohol, divide them by the 300 milliliters. Okay, that'll give us grams per milliliters. And to get to moles per liter, we know that we're going to have to change those grams into moles. And we've been talking in here, how do you go from grams to moles? You use the molar mass of isopropyl alcohol. So you always have to show this step on a test. Even if you get the right answer, I'll be looking for, if you use the molar mass to calculate your answer, and you don't show this addition to get the molar mass, you're going to lose points, even if you get it right. So using a periodic table, we take 3 times the molar mass of carbon, plus 8 times the molar mass of hydrogen, plus 1 times the molar mass of oxygen, and that's the molar mass. So here we go. So like I said, we're going to take the mass of isopropyl alcohol, it's 46.87 grams. Now there's where, don't you see where I kind of did the IOH instead of the C3H7OH. Now, if we stopped right there per 300 milliliters, if we stopped right there, we'd have units of grams of solute per milliliter of solution. And we want moles of solute per liter of solution. So we have to fix both the numerator and the denominator. I think in my answer key, the next term is actually to fix the grams to moles. So we want grams to cancel. We want to be left with moles on top. So we use what? The flipped version of the molar mass. So 1 mole of IOH per 60.09 grams of IOH. Grams of IOH cancel. We have moles of IOH per milliliter of solution. Not quite where we want to be. So now we need to fix the denominator. So if we want milliliters to cancel and be left with liters on the denominator, we're going to put 1,000 milliliters over 1 liter. And then unit-wise, we have arrived. One of my favorite parts of working problems using the factor label method. And a lot of times, this idea of setting it up the way you think it should go and then canceling your units is like a check. Okay, if you don't get the right units, then something's not set up right. Now, sometimes I'll see students work a problem, and it's almost like at the end they're like, well, I'll just go ahead and change the units to what I know they're supposed to be. So we need to round according to what? 3 significant figures, because I have 4 in my grams here, I have 3 in my milliliters, I have 4 here in my molar mass, and of course this is an exact relationship. So 3 sig figs, and I got 2.60 moles of IOH per liter of solution, or big M. You could write that alternatively as 2.60 big M IOH. All this little jargon that you get in Intro Gen Chem. All right. So let's look at the question 3. What is the weight percent? And I already kind of told you to work this sort of problem, if we know the density, which is grams of solution per milliliter of solution, we can ultimately come up with grams of solute per 100 grams of solution. And we won't use the molar mass. So here we go. In this one, it's important to explicitly label, especially your grams. Okay, so if we go ahead and take our raw information, 46.87 grams of IOH per 300 with 3 sig figs mils of solution. Now, we want, can you see how I have mils of solution there, okay? I have grams of IOH, that's awesome, but I have mils of solution and I want grams of solution down here. So if I go ahead and use density, okay, I'm going to use what? The unflipped version, so my grams of solution will cancel. Wait, no, I'm going to use the flipped version, so my mils of solution will cancel. It looks like this. Okay, so there's the flipped version of the density. Notice we wanted milliliters of solution to cancel in the denominator of the first term. So if we use the reciprocal, basically, of the density, mils of solution will cancel. And voila, units that we have in the denominator are grams of solution, which is wonderful. To get it to parts per 100, I think I'm going to take it times 100%. So that's the mass fraction. Throw on to 3 sig figs, which is what I'm allowed, both in the density and the volume. So to get it from mass fraction to parts per 100, we multiply by 100%. So round it to 3 sig figs. I got 16.0% IOH. It's a classic. I know in my other chemistry class when I say it's a classic, we're all grown. Okay. So these will also be due on Monday, and we'll kind of take a quick look, if we can. Where'd you go? Yeah, that's right. Okay. So, dealing with sodium chloride is the solute. It gives the mass and the volume and the density of the solution. So, if you want to put for 107, just like your homework, or just like the example problem in class, it's just like the example problem in class. So if you wrote down the one in class, you should be fine for this one. Let's see. What is the molarity? Okay, in this case, they give you weight percent. I'm just going to let you guys go to it. I guess my only hint is, let's see what my hint, oops. My only hint, it went away, if you want to jot down, my only hint is to make sure you unpack that 5.88%. It means 5.88 grams of solute per 100 grams of solution. Cool. Okay, so now here's my little hint. So, well, it's not a hint, but Monday actually we're going to skip the rest of this about diluting solutions, and we're going to go right to the next part, which combines what we know about solution concentration and stoichiometry. It's wonderful. Okay, that's it.